And we are back. We are working on predicting products and writing chemical equations. The only thing different is that the reactants will be in word form. You will need to turn those into formula form and be able to predict the product and write it in both word form and formula form. Alright, so we're kind of coming down to the end here where we're taking everything that we've done over the last month or so and using all of that. First things first, I want to shout out to my early morning science ladies. You know who you are. Alright, so let's get started. So let's look at this first one here. We have magnesium bromide plus chlorine, and we want to figure out what we get when we put those together. First thing we have to do is identify the type of reaction. So if I have a compound plus an element, we know that that is a single replacement reaction, so single replacement. And we also know that we have to look at the element. What type of element is it? Is it a metal or is it a non-metal? Because depending on what it is will determine what's going to happen with the product. Alright, so here chlorine is a non-metal, so since it is a non-metal, we know that it's going to replace the non-metal in the compound. So chlorine and bromine are going to switch places. Alright, so we know that we're going to have magnesium chloride plus bromine. And notice that I've said bromine, not bromide, because since bromine is by itself, you don't change the ending to "ide." Alright, now let's write that out in formula form. Alright, I'm going to erase a couple things here real quick. So let's erase this. So first thing we want to look at is our charges, because magnesium and bromine is an ionic compound. So magnesium is a +2, bromine is a -1, so that means I need 2 bromines. So I'm going to have MgBr2 plus, and then of course chlorine. We know chlorine is Brinkelhoff, so chlorine is going to be Cl2, and then of course our yield. And then we want to check our charges for magnesium chloride. Alright, so I've got a +2 and a -1. We're going to sneak that in right there. So again, we need 2 chlorines for that magnesium, so we're going to have MgCl2, and bromine also is Brinkelhoff. Here's my bromine. It's also Brinkelhoff, so I need 2 of those, so I'm going to have Br2. Okay, so there is our chemical equation in formula form. Alright, so a chemical equation in formula form. Let's check and make sure if we need to do any balancing. I have 1 magnesium here, 1 magnesium there, 2 bromines in the reactants, 2 bromines in the product, 2 chlorines in the reactants, 2 chlorines in the product. So we're actually good to go. We don't have to do any balancing of the equation in a whole. Okay, not so bad. Single replacement reaction. Let's try another one. Alright, so here we have 2 compounds. We got silver nitrate, zinc chloride, 2 different compounds. And we know when we have 2 compounds in the reactant side, we're looking at a double replacement or double displacement. So double replacement here. Alright, so let's work on our product. If I have silver as a positive cation and nitrate is the negative anion, zinc again is the positive metal ion, chlorine is the negative non-metal ion. So again, opposites attract. So silver wants to get with chlorine and zinc wants to go with nitrate. Alright, so I'm going to change my ink color here. So what we come up with is silver chloride plus zinc. Now let's not forget this. Zinc here is a transition metal. It's zinc 2, so I'm going to keep the 2 there. So zinc 2, and then of course so it's zinc 2 and then nitrate. And I'm going to write it right here because I'm out of room. Okay? So you might be asking, well, you used the Roman numerals with zinc, but you didn't use it with silver, and silver is a transition metal, but remember, silver is always a +1 charge, so we don't need to worry about doing the Roman numeral with silver. All right, let's write it out in formula form. So let's do this. Silver is a +1, nitrate is a -1, so we're good there. So it's AgNO3 plus zinc. So remember, the Roman numeral tells me the charge for zinc. So zinc is a +2, chlorine is a -1. That means I need 2 of those. So it's ZnCl2 yields. Silver is a +1, chlorine is a -1, so I'm going to have AgCl. And then zinc again is a +2, and nitrate is a -1, so I need 2 nitrates to balance that out. So I'm going to have ZnNO3 in parentheses with the 2. So there's the equation. Now let's check and make sure we don't need to balance this. All right, so silver, 1 silver in reactant, 1 silver in the product. 1 nitrate in the reactant, 2 nitrates in the product, so we definitely have to balance this. So let's do that. So since I've got 2 in the product, I'm going to put 2 here. So now I've got 2 nitrates, but I've also got 2 silvers, so I've got to put a 2 here. That gives me 2 silvers, but I've also got 2 chlorines. Well, I've got 2 chlorines over here, and then I've got 1 zinc and 1 zinc, so actually I'm good to go. All right. So there's those 2. Let's with another one. Let's look at this one. We have aluminum plus nitrogen. Here's my aluminum plus nitrogen. All right, so I've got an element plus an element. Of course, we know that is synthesis. Okay, so aluminum plus nitrogen is just going to give me aluminum nitride. So let's write that out. Aluminum nitride. All right, remember your "ide" ending. All right, so let's write this out in formula form. So aluminum by itself is just Al, and whoops, let's try that again. Al, and then nitrogen. Remember, nitrogen is part of Brinkelhoff, so it's N2, and then aluminum nitride. That's going to be an ionic compound. So let's check our charges. Aluminum is a +3. Nitrogen is -3. That actually works out, so we get ALN, and that's it. Simple as that. Let's check and make sure we don't need to balance this. 1 aluminum here, 1 aluminum here, 2 nitrogens here, 2 here, so I definitely need to balance this. So that means I need to put a 2 there. So that gives me 2 aluminums now, so I need to put a 2 there. Now I'm balanced. Pretty simple. How about silver oxide? Silver oxide by itself, that means we have a decomposition reaction going on here. All right, so let's write this out. If I have silver and oxygen, it's going to silver oxide, it's going to decompose into silver plus oxygen. All right, so we have 2 separate elements. So let's look at this. Again, silver oxide, this is a compound. We can check our charges. So silver is a +1. Oxygen is a -2, so that means I need 2 silvers. So I'm going to be Ag2O. And then, of course, that's going to give me silver plus oxygen. Oxygen is Brinkelhoff, don't forget, so you got to put the 2 there. Let's make sure we don't need to balance this. 2 silvers in the reactants, 1 in the product, so we definitely need to balance that. So I need to put 2 there. All right, that gives me 2 silvers on each side, but I've also got 2 oxygens on the product, but only 1 on the reactants. So I'm going to put a 2 there. Okay, so here's a situation where I probably should have looked at the oxygens first, because now I have a total of 4 silvers. So I need to go back and change that 2. So let's get rid of that 2. Well, we don't want to do that. Okay, well, I guess we'll just go back and do this. So there's a 2 there. So in this, instead of this being a 2 now, this needs to be a 4. So now let's check it again. 2 times 2 gives me 4 silvers, 4 silvers. I have 2 oxygens, 2 oxygens. I'm good. All right. Let's do one, actually 2 more. Okay. So I want to show you these two specifically because of the Roman numerals. Just want to make sure we practice on that because I still feel like some of you are kind of struggling with that. So I've got compound and a compound, so double replacement. So if I have sodium as my cation, phosphate as my anion, lead as lead-2 as the cation, and nitrate as the anion. Now, if you guys are able to do this, and you don't have to write the cation and the anion, all right, don't feel like you have to write it. I'm just doing this just to show how this works out, all right? If you're good with it, don't write it. So sodium is going to get with nitrate, because that's the cation of one with the anion of the other, and then lead's going to go with phosphate. All right, so we've got sodium nitrate. We're trying to write small here, plus lead, and again, lead, we're looking at lead-2, so I'm going to keep lead-2, so lead-2, and then phosphate. All right, okay, now let's write this out in formula form. Sodium phosphate, that's an ionic compound. Sodium is a +1, phosphate's a -3, so that means I need 3 sodiums, so I have Na3PO4 plus lead-2, so that means lead's a +2, nitrate's a -1, so that means I need 2 nitrates, so I have PbNO3, and I have 2 of those. So my product is sodium is a +1, nitrate is a -1, so that actually works out great. So I have NaNO3, and then lead is a +2, phosphate is a -3, so that means I need 3 leads and 2 phosphates. So I have Pb3PO4 in parentheses 2. All right, let's try to balance this thing. So let's see, I have 3 sodiums and only 1 there, so now I'm going to have to balance it for sure. I've got 1 phosphate on the reactant side, but 2 on the product. I have 1 lead on the reactant, but 3 on the product, and 2 phosphates on the reactant and 1 on the product. All right, so there's a lot going on here, so let's just try to figure out where we're going to start. All right, so let's just start with the lead, just because we can. All right, so I'm going to put 3 there, so that gives me 3 leads, and that gives me 6 phosphates. I'm sorry, 6 nitrates. So I'm going to put a 6 there. That gives me 6 leads. My goodness, let's try that again. That gives me 6 sodiums and 6 nitrates. So I'm going to put a 2 here, because 2 times 3 gives me 6. And that also gives me 2 phosphates. So let's check it, make sure. I think we're good. So 6 sodiums, 2 phosphates, 3 leads, 6 nitrates, 6 nitrates. We're done with that one. All right, last one. We have aluminum plus iron 3 oxide. So we have a single replacement. Okay, again, we want to look at our element by itself. It's a metal, so since it's a metal, it's going to replace the other metal. All right, so I've got, instead of aluminum plus iron 3 oxide, now I have aluminum oxide plus iron. Okay, so let's put this in formula form. So the aluminum's by itself, so I'm just going to do Al. And then I've got iron 3, so that means iron is a +3, oxygen is a -2, so I need 2 irons and 3 oxygens. So I have Fe2O3, and that's going to yield aluminum oxide. So we have AlO, aluminum is a +3, oxide is a -2, kind of the same thing. So we have 2 of these and 3 of those. So 2 aluminums and 3 oxygens, plus iron, so that's just Fe. And there is our equation. Let's check and make sure we don't need to balance it. So I have 1 aluminum, 2 aluminums, so we definitely have to balance. So let's do this. Let's start with the oxygens this time, so we don't mess up like we did last time. So if I got 3 and 3, I'm good. So 2 irons, so if I put a 2 there, That gives me 2 irons. I got 2 irons. I have 2 aluminums, so that means I need 2 aluminums there. Let's check and make sure. 2 aluminums, 2 aluminums, 2 irons, 2 irons, 3 oxygens, 3 oxygens. We're good. Alright, I know that's a lot, but hopefully this will help you out, and we will see you later.